and start recording stuff. Okay, so 6.2 is fraction rules. And again, we're still in the expressions, so no equal signs. We're not solving anything, we're just simplifying. So, I guess I should put no equal sign. So all we can do is simplify. So Danica said how we multiply these two fractions. It is straight across the top, straight across the bottom. So 5 times 1 is 5, and 7 times 2 is 14. Can I reduce that? No, so I leave it there. We've just multiplied fractions. Pretty easy. So if you can do it numerically, you can do it algebraically, okay? But you can't make up new rules just because there's letters in them. You still have to follow the rules of fractions. So dividing fractions, if I have 5/7 and I divide it by 1/2, what do I do?
Do you flip the second one?
Only the second one. You only flip the second one. So this is going to be, it's going to change to 5/7 times 2/1. So the little monster says when dividing fractions, take the reciprocal of the second fraction, then go ahead and multiply. So that's going to be 10/7. Can I reduce that one? The answer to that is no. So we'd stop there. All right, everybody good? So those are your rules with multiplying fractions. You learn them, I don't know, when did you start learning these rules? Grade 7, grade 8, grade 2? Right now, we just got them right now, perfect. Okay, so now we're gonna add letters into things. So this is my friendly hint, my thing I want you to know. Friendly hint, do not multiply the factors through, leave them as factors. It's gonna be easier to do your NPVs and your simplifying. So before you multiply anything through, just don't do it. And what I mean by factors is leave them like x plus 2 times x. Instead of leapfrogging that x in, I'm just going to leave it like that because it's easier to cancel stuff out than it is when you multiply it through, then you get to unfactor. It becomes cumbersome. Okay, so remember the steps. Factor everything, do your NPVs, simplify the terms, multiply or divide. So I said simplify each term if possible. That just means within that term. Multiply or divide. If you divide, you have to do your NPVs for the reciprocal. Because going back up to our numbers for a second, I had a denominator of 2 here. When I flipped it, what do I have now? I have a denominator of 1. I've got a new denominator. So when you get a new denominator in dividing, you have to go back and do your NPVs on that one. Okay, and then you're going to simplify the entire expression. So much fun. Okay, example numero uno. What do we do first? Factor everything. So factor everything. So I'm going to factor this one. So what are the factors of -12 that add up to -1?
-4 and 3.
Right, so negative a minus 4, a plus 3. I'm looking at the bottom here. What is that? That's your difference of squares, right?
Also, a take away 3 and then
A plus, sorry, wrote the plus 3 first, but yeah, a minus 3, a plus 3. So now we are multiplying by the second one, and the second one, what are the factors of positive 3 that add up to -4?
-3, -1.
Right, -3, -1. So you see how being able to factor helps you do this a lot easier. If you're still struggling with the factoring, I encourage you to continue to practice or do this math off on a separate piece of paper. There's so much that we have to do within this question. If you're struggling with the factoring part of it, do that on a scrap piece of paper, because I find sometimes when we put everything on one piece of paper, you lose the actual math in it. Okay, so this one down here, is that a difference of squares?
No.
No. Can I common factor something out of that? A. If I take an a out, I'm left with a minus 4. right. Okay, so we've factored everything. We've done step one. That's what step
Wait,
one.
what do you mean? What did you call it? It's
This one, what I just did here, I called it common factoring. Okay, all right.
no, like, why could you do it with the 9 but not the 4?
Okay. Is that okay? So you're right. The a squared is a perfect squared, and the 4 is a perfect squared. But what's attached to that 4? It's got an a. This thing is not a perfect square, so I couldn't. You're right. You're on the right track. Like that's odd. Like it's. So that's a tricky one. Like it looks like a difference of squares, but that a on the end is throwing us off. Okay, so all I can do with that one is common factor. I can't get two binomials. All right, so step 2 is non-permissible values. So NPVs. So A cannot equal, and let's see if we can do this without doing equations for it. So what's happening here? A cannot equal for this one. -3, right? So if I'm going to do the math up here, that would be a plus 3 equals 0. So that'd be a equals a -3. And that, remember, the denominator can equal 0. So a cannot equal a -3. It cannot equal a +3 either, because both of those are taken care of. Now we hop over to here. What can this a not equal? Zero. Anytime it's a variable by itself, it can't equal 0. There's nothing to it. What about this one here? +4. Okay, so those are my MPVs. Plus or minus 3, 0, and 4. Everybody good? All right, so let's cancel out. I said this is step 3. Simplify in each term. So this is a term, and that's a term. So is there stuff we can simplify? Is there stuff I can cancel out? When I say simplify, that's the exciting step. We can cross stuff off. In term 1, is there anything I can cross off?
A plus 3.
A plus 3. Okay. And the reason why we want to simplify that term is because then we're dealing with less terms. You can do it all in one step when it's a multiply, but it's a little bit cumbersome. What's happening here? Anything I can simplify in term 2? No, that's it. So I have a minus 4 over a minus 3 multiplied by a minus 3, a minus 1 over a times a minus 4. How do we multiply fractions? Straight across the top, straight across the bottom. So this is where I'm telling you not to multiply things together, because it's a waste. Because you're going to multiply them together, and then I'm going to tell you to take them apart. All right, did I flip anything? Are there any new denominators? No, there's no new denominators, so I don't have, you only have to do your second round of MPVs if you're doing a division. So now I can go ahead and simplify because I've multiplied everything together. Is there stuff I can cross out?
A minus 3.
A minus 3 goes. What else goes? A minus 4 goes. And what am I left with? A minus 1 over A, where A cannot equal plus minus 3, 0, and 4. And Pablo's going to ask me, do I need to rewrite my NPVs? The answer is no if they're clearly stated somewhere that I can see them. This is the most correct answer, though, because you're stating the solution and you're giving the restrictions.
Doesn't, I was gonna like
What were you going to ask, Pablo?
like 8 divided by 8, wouldn't that cancel out?
Oh
Or
my
is it
goodness, you
minus-
just killed a kitten. You just killed a kitten, Pablo.
Why?
You're a monster. Monster. Because remember, this is like saying A goes into here and into here. So, yes,
Alright.
so we talked about this before. You could write it like that, which would simplify to 1 minus a over a, right? But that denominator has to go into both, and people get into the habit of crossing those out and saying the answer is -1, and you would be the terrible person who killed a kitten by doing that. Don't be that person.
I was just questioning, and I didn't kill a kitten yet.
Perfect. I appreciate that. So, I mean, you could do it and write it this way, but I find this was really cumbersome, and this is just neater, and I can walk away at this point. Like, I'm done at that point. So I would leave it here. But this would also be a correct answer. Okay, all right.
Pi in the next one.
Pi. What is pi?
A number.
It's just a number. People freak out, but it's just a number. It's 3.14159 and a bunch of other numbers behind it. We give it a symbol because it's so long and nobody wants to write out all the digits, right?
Learn all of them.
It's infinite.
Okay.
I'm just gonna sit here and memorize the digits till I die. And I still wouldn't have succeeded. And then you'd have to carry on my legacy, and then you'd sit here until you died, and then your children, we wouldn't have children because all you would have done is sat here and memorized the digits to pi. No life other than pi. Okay, so looking at this, step 1 is factor everything. Is there anything to factor? No. This one's nice. There's nothing to factor. So if I multiply the top, I'm going to have d times 2 times pi times r times h. And we know they're all multiplied because there's no operation in between them. And then on the bottom, we're going to have 2 times pi times r times, and this d minus 2 is connected together. So I like to put brackets around it. Even though it doesn't have brackets here, I like to put brackets to indicate that this is all one term right here. All right. What do I do now? Nope. Step 1, factor everything. Step 2 is not yet. Nope, nope. Non-permissible values. All right. So,
Is it just D plus 2 or whatever?
okay, so that's 1. D cannot equal +2 because you got that from there, right, Danica? And R, what about R? What can R not equal? I'm gonna hop back to 0 because remember A here, what did that not equal? When it's a single variable, so R cannot equal 0. It's okay to have different variables, that's fine. Hey, I'm just gonna send a
What
text
about
message.
H?
Is H on the bottom?
Oh, it's not.
Right? So although it is a variable, you're correct. The only thing we care about is our denominator's not equal 0.
Wouldn't pi be one of the?
Is pi a variable?
No, but wouldn't be both the numbers that both variables can.
Pi is just a number. We just talked about it. It's 3.14159.
Yeah, but asking would be a restriction.
No, it's just a number. Because pi is one thing only. Pi, if I ask you all what pi is, you all know it's 3.14, right? Yeah?
Yeah.
So that's not a variable because it's a specific number. We just have a pretty symbol for it.
I know, I didn't say it was a variable.
Oh.
I was asking if it would be part of our non-permissible values.
No, because non-permissible values are only for variables. And pi isn't considered a variable, it's considered a symbol. Oh, so confusing. So confusing. Just wait till we get into epsilons and stuff like that. Sorry, just gotta send. Okay, sorry. IT needed to know where software was, and I don't have it. Okay, so we've done our non-permissible values. Now what do we get to do? Cancel stuff out. So I'm going to cancel out the 2's. I'm going to cancel out the pi's. I'm going to cancel out the r's. Now, Pavlo, can I cancel out the D and the D here?
Yes.
No, you monster, you. Oh, you're a monster. I can't do that because that's a set, right? That's a set. So you can't.
Let him walk into that one.
I did. I lured him in and just bonked him on the head. That's a set. You can't break that up. So what's left on top is DH, and what's left on bottom is D minus 2, where D cannot equal 2 and R cannot equal 0. I think the monomial ones are harder than the ones you have to factor, because these ones get confusing. The simplest are always the hardest. Okay, we ready to flip the page? Feel like it's story time. All right. A division question. Oh no. Oh no. Okay, step 1. No. Step 1. Factor everything. What are the factors of -7 that add up to a -6?
-7
Yep. -7 and +1. What about that denominator?
Perfect. Difference of squares.
Difference of squares. So the faster you can identify these things, the easier it's going to be to do the questions. So factors of 7 that add up to 8. 7 and 1. And so if you're sitting there and thinking that people have like wizardry for doing this, it's just they've caught on to the easy way of factoring quicker. But like I said, just do it on a separate piece of paper. Denominator here,
You can C go to C.
take out a C. So we're going to common factor out a C, and we're going to be left with C plus 7. Okay, what do we do now?
NPV.
NPVs, beautiful. NPVs. Okay, so remember I only care about denominators. So C cannot equal.
Negative and positive 7.
Okay, so I'm going to do plus minus. I'm going to put it the right way around this time. Plus minus 7. What about over here? What does this one can equal?
0.
0. And this one? -7. It's already stated, so you don't have to state it again. You only have to state it once. Okay?
Will you mark it wrong to state it twice?
No, because you're not technically wrong, but I will mock you, probably.
That's not right.
True story. Okay, so now what do we do?
Cross out stuff.
Okay, so we simplify within the term. You guys don't actually have to do this step if it's messing you up. So what can I simplify in this term? C minus 7. Gonzo. Okay, moving over to the second term, what can I simplify? C plus 7. All right, so I have C plus 1 over C plus 7 divided by C plus 1 over C. Okay, what do I do now?
Now we divide them, we flip them.
We flip them. We reciprocal it. So remember that we only flip the second one.
Yeah.
So C plus 1 over C plus 7 multiplied by the reciprocal, which just means to flip it upside down. So none of your fraction rules have changed, like whether you're using just numbers or whether you're using numbers and letters. But what we have done is we've created a new denominator. So as soon as we have a new denominator, we have to do the NPV for it.
Is it -1?
It is. So I'm just adding it to my list. Right? Just going to put a new denominator. Therefore, new NPV. You guys know that a triangle of dots means therefore?
Yes.
Okay, good. All right, and that new MPV was -1, which I just added to my list.
Do we get to cross another C?
Now we get to cross more stuff out. So what do we get to cross out?
C plus 1.
C plus 1. So I didn't have to rewrite it like in, I don't know, in this example, I wasted time and I multiplied it, but then I rewrote it all as one numerator. You don't have to do that. You can cancel out from here to here. Because really, did anything change from this line to this line? No, except they were all in one fraction. So I'm just going to go ahead and cancel stuff out. What's left over?
C over C plus
And then comma C cannot equal plus minus 7, 0, negative 1. So not hard, but there's some steps to it, right? And if you rush through it or skip things, you may run into problems that you're missing stuff.
Oh, wait, Miss Gallen.
He's gonna try
Am I killing kittens? Because, like, C divided by C.
Yes!
7.
Yes, you're killing a kitten.
What? Okay.
Because this is,
C goes into
this,
C and 7.
Oh,
like-
you do that for, yeah.
right, like that's a set, right? And then if you divided C by C, does that mean the answer is 1/7?
Well, if they're in a bracket, then no.
Okay, so even though they weren't in a bracket, we know that this is a set because they were in a bracket right here. I just dropped the bracket because they were the only thing in the denominator. But if that helps remind you, this is a set. You can't break it apart.
Okay.
Whoa, killing kittens everywhere. I'm a little nervous for him. Okay. Example numero 3. We've got a divide and we have a multiply. So first of all, let's revisit BEDMAS. Order of operations. So I'm going to write it out. We have no add or subtract. We have no exponents. So what am I looking at? I'm looking at the multiply and the divide. What's the rule for BEDMAS?
Divide first.
The rule is you do the divide or multiply as you see them reading left to right. Everybody remember that? So really what we're going to do is we're going to do this first. We're going to get a quotient here. And it's a quotient because there's dividing. So the name doesn't change. So we're going to do this. Whatever the quotient is, then we're going to multiply it by that third set. Make sense to everybody?
Yeah.
Okay? Just like if you were to do 10 divided by 5 multiplied by 7, you do this first, get 2 times 7 is 14. Right? So we're going to do the exact same thing, but with algebra. So step 1 is factor everything. Factor everything. You can save yourself some time by literally factoring all 3 sets in this. Okay? So top, I'm going to common factor out of 3. Oh, bottom. Wah, wah. Okay, what's happening with the bottom?
It has a coefficient on the x.
Yes, and does that make me sad?
It makes me sad.
Makes you sad? Okay, I'm grabbing a scrap piece of paper. Okay, because I only have limited room on my sheet. So 3x squared minus 5x minus 12. So I'm going to multiply the 3 by the negative 12 and get negative 36. What are the factors of negative 36 that add up to negative 5? Negative 9 and 4. So negative 9, positive 4. So I'm going to have 3x squared minus 9x plus 4x minus 12. Looking at these, I'm going to common factor out of 3x, and I'm going to be left with x minus 3. Looking at those, I'm going to common factor out of 4. I'm going to be left with x minus 3. I know I've done it right if this one and this one are the exact same. So if I take out an x minus 3, those are gone, and I'm left with 3x plus 4. Whew. So I just did that on a scrap piece of paper as not to clutter my math. All right. Okay. I think I can do everything else without scrap paper. All right. So I've got divide by, 12 is just a number. 3x plus 4, nothing I can do with that. Multiplied by, I'm going to factor out a 2 out of this one, so 2 bracket x minus 3, and then I'm going to be over x plus 4. Okay, so I have factored everything. All right. So what comes now? No. NPVs. You can't have fun until you set your restrictions. You're just ready to cross stuff out. So x cannot equal, this one's going to be positive 3. This one's going to be positive 4/3. This one's going to be negative 4/3. And this one's going to be negative 4. Ooh, sorry. That is a lot. And they've gone kind of off my page here. Okay, so remember what we said? We're going to deal with these two first. All right, so we're dividing, so what do we do? Flip. So we flip only the second one. So x minus 3, 3x minus 4, multiplied by 3x plus 4 over 12, multiplied by, you can't forget this because it's still part of the expression. We're just not dealing with it right now. Ooh, we can deal with it all right now. Oh, that's exciting.
Why do you have a 3x minus 4? That is 3x plus 4.
You're right. Sorry. So what about this one?
So then we don't have one.
So we don't have that one. Oh, scallion. Jeez Louise. Okay, we flip something. So I have a new denominator, right?
Oh, is that a 1?
But there isn't. So it's a new denominator of 12. There's no variable in it. So in this one, even though we have a new denominator of 12, there's no variable in it. So there's nothing x, like 12 is 12. It's like pi, right? It's just a number. So we actually don't have to add anything to our list. Okay, so now everything's multiplied together. We can cross stuff out now. Okay, so I'm just gonna go crazy. Do those, I'm gonna do that, and I'm gonna do that and that. And you guys know that it has to be matching top and bottom. Like you can't, if you have an x minus 3 and an x minus 3, but they're both on the denominator, you can't cancel them out, right? Yes? And everybody knows why we're canceling them out, right? Because this divided by this gives me a value of 1. We cancel stuff out sometimes so we don't actually think about the math. It actually equals a number, ladies and gentlemen. So we've got 3 times 2 left on the top and 12 on the bottom. So that's 6 over 12. Are you going to leave it like that for me? Never.
Where did you get the 2 from? In 3 times 2? Okay.
That 2 over there. Where x cannot equal 3, negative 4 over 3, and negative 4. So sometimes it actually does equal a number.
How often does that happen?
Not very. Not very.
Let's get our hopes up.
I like to get your hopes up, but I just wanted to show you it's a possibility. Okay, that's it.